Again, my name is Bill Hubbard. I am part of the extension team with IBIS, and this is what we're calling the internal webinar series. And the idea is designed to bring everybody up to speed within the project on some of the activities going on, and to introduce you to some of the principal investigators and researchers involved. And this month we have Dr. Tom Gallagher from Auburn University. He's Associate Professor of Forest Operations, and he's going to present on harvesting practices for improved efficiencies in biomass production and supply. I won't take a lot of time with how to use the system so much, but if you do want to use your microphone to ask a question, to get involved, that's great. Just raise your hand first. That way Tom can turn off his microphone and we won't get a lot of reverberation, and then we'll grant you access to speak. So when you're not speaking, just make sure your talk button is not highlighted, and I look forward to an interesting presentation. So Tom, whenever you're ready.
All right, thank you, Bill. I'm going to assume that everybody can hear me. If not, type something in. If you have questions during the presentation, feel free. I'll try to remember to keep an eye on the chat room. If a question pops up, I'll try to address it as we go. Plus, there'll be, of course, time at the end to go through questions. So let's see. I'm also a little worried. I see there's 47 slides. I think I only had 42, so there's no telling what those extra couple slides may be. But we'll get started with it anyway. Thanks for everybody jumping in. I recognized almost all the names. There's a few I'm not sure of. For those that are in the forestry end of things, this is going to be a lot of review, but this is kind of what I thought we could review on and discuss where we might go from here. So first I want to talk about current systems, and there's three general areas that we think about as we produce biomass, and those three systems are what we call whole tree chipping, or at least what I call whole tree chipping. There's this area of clean chip residuals, which some people call CCR, and then there's the area of residue chipping. So we'll kind of go through each one of those. Whole tree chipping, you know, it's been around for a long time. I want to say since the early 70s, there's been various opportunities of whole tree chipping out there. Most of them are large independent operations. Most of the time they're dealing with small diameter material. They were originally used for land clearing, and then the diameter was up and down depending on what the material started out as. But now they've kind of progressed to where they're just, especially as it relates to biomass, they're small diameter material. They're usually doing some kind of understory clearing. They can be used for land clearing. I was recently down in Florida, and there was a lot of land conversion going over to farming that they were doing some land clearing on, and then you can get larger diameters. But most of the time what we're talking about is understory removal, where it's pretty small diameter material. Of course, the chipper, it's a chipper involved, anywhere from probably 450 up to about 800 horsepower. Some of them are fed by a separate loader, which you see in the back on this one. Some of them will have a loader attached. There's lots of manufacturers out there, Moorbark, Bandit, Peterson, you know, several different manufacturers out there. Typically the material is harvested with a wheeled fella buncher, you know, with a saw head or a shear head on it. You know, very common machinery. It's been around for a long time. You know, no surprises here. Very proven system. But a wheeled fella buncher, harvesting anywhere from 10 to 15 loads a day. Brought to the chipper via a wheeled skidder, and you can kind of, you know, in terms of understory removal, you can kind of see diameters in there, you know, anywhere from 2 to 3 inches in diameter up to about 6 or 8. Once in a while there may be a big tree for whatever reason, but lots of small stems, and then they're feeding them entirely into the chipper. In this case, this is the same operation. You can see the loader feeds them. A lot of variability in the material. You know, you see he's blowing it into the van. Those you get maybe not familiar with, we call these dirty chips. Just from the standpoint, it's not the fact that there is some dirt in them, but a really small quantity. They're dirty chips from the standpoint of that they have not only wood, but they have bark, needles, leaves, whatever else. As you can see from the pictures that I have on right now, it can be pretty small diameter and ratty stuff, but if all it's going to do is be used for biomass, especially right now where it's just being burned, it doesn't matter what the makeup of the material is. Those are the majority of the systems out there right now. The pictures that I just showed you were from various fuel operations that I've seen, in most of the southern states. And again, wheeled loader, regular size, conventional skidder being fed into a chipper. We do have a project here where most of the way through right now, where we put together a dedicated system specifically to handle a large number of small stems. We consider these to be loblolly pine fuel plantations, energy plantations, grown on a 9 to 12 year rotation. Lots of stems per acre. In this case, there was about 600, but we can foresee 8 to 100 to 1,000. We put together this system. It was a track machine, as you can see, a boom type machine. So instead of driving all over the stand like a wheeled machine would have to be, this would reach to the different trees. The high production felling head. It was a shear head, capable of handling up to about 15 stems. Though we found some difficulty in getting that many, but it could theoretically handle up to about 15 stems. Very high production system. We mated it with a fairly large side Tiger Cat skidder. This was a 630 with quite a large grapple on the back to handle the multitude of small diameter stems that would be piled by that fellow buncher. The difference between this system and the first wheeled systems is most of the systems that are currently out there on wheeled systems, they're only handling about 10 to 14 loads a day, whereas this system, as we described it and checked the productivity of it, they can get if they can get the trucking to do what it's supposed to do, this system with the 2 machines, just a fellow buncher and 1 skidder, could probably produce about 20 loads a day. So it's a much more productive system, again, with the idea that you'd be handling clear cutting small diameter stems. The rest of this system is that it was put into a chipper. In this case, we were producing clean chips. But the idea behind the system originally was that it would be for producing fuel or dirty chips for the energy market. Bottom line is all those were whole tree chipping systems. Again, they're generally large independent operations. Small diameter wood, land clearing, and understory removal. You're going to get wood, again, depending on if it's clean chips or dirty chips. You're looking at something that's going to be heavy to wood, probably 80% plus. And you're going to have that 7 to 9, 10% bark, and about 10% is going to be in needles, foliage, anything like that. So that's whole tree chipping. The second category that I think about when I talk about biomass and fuels is clean chip residuals. It's important to understand that this is a byproduct from a clean chipping operation. So if you don't have clean chipping, you don't have any of this material, and it's almost always going to be reprocessed through a grinder, which means that the quality of the material is probably not as good as you're going to get in terms of the actual pieces of the material. It's not going to be as good as you get through it from a chipper. Example of this is, there's various chipping machines out there. This one here is a Moorbark. Right in the middle of it, you can see a ramp going up where there's needles, leaves, bark, limbs, and stuff like that come out. There's other machines that's pushed out the bottom. The Peterson is known for just having a ram down there that pushes the material out the bottom. It's then pushed up into a pile and left standing for another operation that will usually come by a short period of time later, which is a grinding operation, usually fed by some kind of front-end loader. The contrast isn't very good, but just in front of that front-end loader, you can see the material all kind of piled up. And then what will happen is he will grab that with his forks on the front of that front-end loader, and you can kind of see this one. He's on the back side of the machine. He's about to dump a large bucket full into the grinder, which then processes the material through and into the truck for delivery, again to the biomass plant. The quality of this material is quite variable. It's obviously less wood and much more needles and bark. Dirt can be a problem. And that really falls back on time of the season, and also who the operator is. Some operators are very good. They make sure they don't pick stuff right off the ground. They make sure they don't push up too much stuff off the ground. But I've heard a lot of different stories on this material. I've heard of people showing up with loads as much as 15 and 20% dirt in the material. And that's obviously going to be a serious problem down the road from these operations. Just to let you know, we're not the only ones looking at this material. There's a nursery market. The horticulture department here has done a lot of studies on using this material to grow both annuals and perennials in the nursery business. Their source of material, which was peat out of Canada, transportation cost, the availability of it is becoming an issue. And they started doing a lot of studies here, growing material in it, and they found it extremely favorable. The disconnect there is they don't need that much of it, and we're still kind of working through the situation on how to take it live or how to make it operational. These guys want 1 load a week, and we have operations that will produce 8 to 10 loads a day. But again, it's all ground, so you get a lot of variability in the material, not as much wood, much more needles and bark, and that's going to impact the ability to process the stuff. The third category I always you hear a lot about is what I call residue chipping, and that's the byproduct of roundwood harvesting. Everyone's been past a logging job and seen that big pile of tops and limbs, and some loggers do a pretty good job carrying it back to the woods just to spread it. Some carry it back to the woods to put it in the skid trail to reduce compaction and fill in wet spots and things like that. But the important thing about residue chipping is that you understand that it is a byproduct of harvesting. So you got to have those operations before you're going to get any of this material. It's typically low volume. Examples of that is this was an operation not far from here. He used 1 loader and he'd fill a truck up, as you can see in the back, and he'd load a truck and he'd just take the tops and limbs and things like that were coming off that material and process them through the chipper. Small chipper, maybe 325 horsepower, capable of, this operation was only generating about 1.5 loads per day on 8 loads of roundwood. So not a lot of material. And again, he used it mostly to clean the site. You can see this was a thinning operation. Another operation we had nearby, he actually set it up as a separate entity. If you look on the left of the picture, you can see the loaded truck, and just behind the loaded truck you can barely see the loader there. He actually had a deck where he did all the processing of his roundwood on one deck, and then he pulled the material over to this operation, and he was getting 3 to 4 loads a day of residue chips. So he was getting about 16 loads of roundwood a day. So it was about a 1 to 4 ratio on this job. So the bottom line is it's not a lot of volume, but this is the material that Steve Taylor likes to call the low-hanging fruit, because it's already on the deck, it's available, it does have to be processed. It's not a highly productive operation, but there's still a lot of it out there, and probably where we'll see most of our material come from, or at least the first place where most of the material gets utilized. Again, it's typically low-volume operations. You can have dirt problems if it's wet out, and depending on how much it gets pushed around. Again, that's going to fall back on the operator. You're going to see a lot of variation. Typically, we did some sampling here on a study that we're doing. We found about 75% wood, and the rest was sort of evenly divided between bark and twigs and needles and things like that. But it can vary quite a bit. We had some with as low as 60% wood, where there was a lot more needle material. We've had stuff as high as 80 and 85% wood, when it was just some pretty good top wood off of hardwood jobs that went in. So that is a lot of variability in this material. More than I guess the take-home message on that. Short rotation woody crops, which of course is where we're looking at right now, and what this study is going to mostly concentrate around. It's still very much developing. There's a lack of machines. Everything that I've shown you before are time and tested machines. There's lots of wheeled fellow bunchers and skidders. There's half a dozen chip manufacturers, being fed. Chippers are being fed by loaders. There's several manufacturers out there. There's all kinds of history out there. We have good history on productivity rates, on cost, on operation cost, repair rates, all that other stuff. The short rotation woody crop end is quite new, and there is definitely a lack of machines. As a matter of fact, as I know it as we stand now, there's only a few machines that are out there and available. One of those is the New Holland harvester. This, in the example you see here, was on a willow plantation outside of Syracuse, New York. The New Holland basically took a silo harvester and kind of put a little more beefed up harvesting head on the front of it. You can see it's a fairly decent sized machine. It's not a cheap machine either, and those issues are going to come into play in just a minute here. You can see a little more design on the head. It has a pair of saws that actually cut the material off. In this case, it was willow, so it's a nice clean cut, and it then forces the material into the chipping. I should go back and say this was a sort of a research demo example, and you can see he's just blowing the material onto the ground. Typically, this would be blown into some kind of bin and brought out to be reloaded into trucks. But this being a research example, they were just kind of showing us the machine. They weren't going through that phase of it. So you can see quite a beefed up head. Did a really good job. I mean, he was able to go right down the row. Again, this was a willow plantation in Syracuse. You can see fairly small diameters. Most of it was probably less than 2 inches in diameter. Multiple stems, 5 to 8 stems in many cases. Not quite what we're looking at. As I understand it, I haven't been able to get some of the folks to tell me exactly what we're looking at, but I think we're looking at more like 3 to 5 stems, and hopefully in the 2 to 3, maybe 4-inch range if we're looking at this eucalyptus. We put some of that in the ground, and we're waiting to see how it comes out, and if we're going to be able to have something to try some of these machines on. If not, we may have to take these machines, something that whatever we decide to put together, we may have to go on the road and test. Important aspect of this machine that needs to be noted is the nice clean stools that are left by the saws, and that's very important consideration with this short rotation material. If you don't have good clean stools, you're not going to get the regeneration back that you want. And so what that means is a lot of times they're talking about that's probably going to limit the harvesting time frame that's available. Again, we're still going to have to try to test some of this, but it appears it's probably going to have to be a dormant season harvest if we're going to protect the stools so that they properly regenerate. And this machine, as we saw it, is doing a very good job of that. There's another machine that was tested at the same site, and this was the BioBaler, and there's been several testings of this. This was the Willow test up in Syracuse, New York, on the same location. The Forest Service down here at Auburn has tested this down in Florida on various material, including, I believe, some eucalyptus. And you can see same kind of deal. He knocks it down, and then the problem with this BioBaler is it actually it'll cut the material and grind it up, put it into a very nice little bale that's easily transported and from the site. Which that's one big advantage of the BioBaler is that it puts it into a very handy transportation unit. These are about 1,000-pound bales, but you can see the material, it's somewhat stringy, so it's going to have to be reprocessed. The really downside to the BioBaler is what it does to the stool, and you can see it tears it up really, really poorly. And that's a real issue. Again, I have not been able to verify this going back to this site since it was up in New York, but in talking with a lot of people on site that are familiar with coppice material, and this is not going to regenerate very well, and that's a problem with the BioBaler. So it kind of goes back to the idea we need something that's going to cut and make for a real nice clean cut so that we get good coppice from whatever machine that we want to deal with. So the idea behind short rotation woody crops is that it's still developing. There's not many machines out there. Situations that we have to think about is it's kind of a two-edged sword. We're looking at a short harvest window to protect that stool, where the discussion is we're probably looking at a winter harvest. And of course the problem with the winter harvest is it's poor winter harvesting conditions. Sites are usually wet. If you go back and think about that the New Holland bale that I just showed a few slides ago, if you look at the size and weight of that machine riding on those 4 tires, the guys everybody in the woods knows that definitely is going to be a problem in a winter site, because you're going to have rutting and sinkage and sinking and everything like that. So the poor winter harvesting conditions are going to be a challenge for at least as the machine that you saw there in terms of the tires and the size of it and the weight of it. The other problem that you have is if you go with this short harvesting window that we're being told we have to consider, you have something, any kind of dedicated machine is going to leave you with low utilization. If you got a harvest of, say December to March, maybe November to March, that's 4 months long. You got a machine that's sitting in the barn for 8 months. Who's paying for that? And so that's going to drastically impact cost. So the machines that we currently see, namely the New Holland one, which probably has the most study time on it, and in terms of a product is probably the most advantageous out there, has a serious cost issue. Some of the other machines that maybe you'll get other uses out of aren't producing the product that we want. An example of that is the Fecon machine. This has been tested. This was a test done by Joe Rossi at NC State. In this application, it was being used as just to do fire reduction, fire hazard reduction, places where they can't burn. They looked at using this machine to go through and process all this cellulosic material, blowing it into the van behind it. That van was then, I'll show you in the next slide, it's brought out and dumped. But again, it's back to that grinding head. Now in the application that you see here, where it was used just to process material for fire hazard reduction, grinding head isn't a problem because you're not worried about any kind of reproduction situations. And but it's a good size head. You can see it takes about an 8-foot swath. It's a track machine, so you don't have the flotation issues that you might have with a wheel machine. All that's real good. It brings the material out and dumps it into, in this case it was being dumped into a bin. It was kind of stringy material, which would probably have to be reprocessed at the plant, but it's still a chip material that can be handled and transported, by our current technology. This was an example of it being tested. I believe the Forest Service was down in Florida, where they were grinding up some eucalyptus plantations down there. Again, the flotation situation you can see is, of course this is a dry sand, but even if it were to be wet, you got a track machine that's going to do pretty well. You got a wire tire, on the transport system that brings it out roadside. The problem with it, as it was tested on that site, is this is an example or a picture of the stool that was left, and you can see that the grinding head is, the odds of this regenerating is almost non-existent, and so that's probably not going to work in our case. So the current technology, kind of summary of the current technology that we know that's out there as it relates to short rotation woody crops, is we're looking at what is defined as expensive machines. The New Holland machine was over a $400,000 piece of machine that's going to, as it stands, going to see low utilization. If you're only looking at about a 4-month harvest window. And the last thing to think about all the machines that I showed you in terms of as they related to short rotation woody crops is they were all doing some kind of chipping and grinding of the material. So that had us thinking about where could we go with this. I mean, at some point in time when we get maybe some of our eucalyptus or poplars up to snuff, we can bring some of these machines down, do some production studies, do some cost analysis, but that's going to, as soon as we get those plantations together. But that kind of says, where can we go from here? And this is my idea of, where I think maybe the IBIS research can head. And that's in the idea of some kind of new felling head that I see mounted on a conventional fellow buncher. We have, very tried and tested fellow bunches out there, wide tires on them, so for good flotation. Cost of them is not outrageous because they've already been built. We're not trying to reinvent the wheel. They can be used for other things, and that's very important. But if we can come up with some kind of felling head that can be mounted on a conventional wheel-type fellow buncher, I think that we can reduce a lot of cost and give us a lot of flexibility. The idea being that we could cut the material and pile it in some form or fashion. That's still what we're working on. That way, then it could be skidded or forwarded out to a landing where it could be further processed. The reason, my thought process behind this is, again, the current technology you saw where they were grinding or chipping the material, and what a new felling head would allow us to do that just cut and pile the material is it give us the opportunity for transpirational drying, which could be quite beneficial. On a little DOE project down here, the Forest Service completed some transpirational drying study. It was on a site down in South Alabama. It was about a 12 to 14-year-old stand. I'm not sure of the date of that, but what they did was they cut material. It was felled, laid down on the ground. They took aside 20 trees. They weighed them at 0, 3, and 6 weeks. They cut some discs from various trees, destructive sample to get the moisture content. They also did a final chipper analysis at harvest by sampling from the material that was on the ground. They sampled 17 different loads. What you can see there is this was the graph of what the drying looked like. They only sampled a few trees, and they assumed that everything was started at that 56% moisture content. But you can see where in 3 weeks and then at 6 weeks, you saw about from moisture content from above 55 went down to 40 and then dropped all the way to 35. That was on the disc samples that they took and the weight of the trees. And then what they did was they actually sampled the chip van, after the material was processed. And you can see in the woods they got sample weights, sample moisture contents are down around 35%. When they sampled off the chips that were blown in the back of the van, it was more like 40%. We actually did a similar study with bundles a couple of years ago, and we kind of learned the same thing: is you can't just weigh the trees and assume moisture content is dropping. There's also mass loss. So bottom line, you still get about you have an opportunity for about a 10% moisture loss over 6 weeks. And our people in the woods that are doing our processing, our conversion folks tell us that moisture content loss is huge and can be very beneficial. The cost of doing that is still kind of up in the air, and so that's who's going to pay for that. If we fell it and come back, there's operational considerations. There's 2 visits to a site, all that costs money. There's still this question mark: are we better drying it in the woods, or is the processing people better drying it in the plant? But the bottom line is, if you chip the material at the stump, like the New Holland machine did, like the Fecon machine did, you're not going to get this opportunity. If we could come up with a machine or develop a machine that could maybe leave the trees whole, and we have the opportunity, at least the consideration of the transpirational dry, we might be able to see some good benefits from that. So again, I'm kind of winding down here. This is where we're headed, or this is where I thought we could head, and I'd love to hear from some of the other participants. The idea behind a new felling head, again, that can be mounted on a conventional fellow buncher. It would reduce a lot of costs. Instead of putting together a dedicated new, harvester at $400,000 like the New Holland is, if we could develop some kind of harvesting head, $80,000, $75,000 to $100,000 that could be mounted on a conventional fellow buncher, you could improve utilization. I see loggers, that could possibly, you could have a logger who cuts roundwood, cuts for conventional job for 8 months of the year, and then switches over and cuts these short rotation crops during the winter months. So he's going to get, year-round utilization of the system, which of course is going to do, hinge upon, being real important to reducing those system costs. Again, he could take his fellow bunch of skidder, roundwood for 8 months, then go on short rotation. Question marks of whether we can skid or forward or how that would go, but, cut the material, leave it on the ground, let it dry, or potentially harvest it green. But, again, short rotation crops for several months, roundwood the rest of the months, improves utilization, hopefully lowers cost, reduces capital cost, and that he's only buying a $75,000 head and not a whole system. So let's see, I'm sorry, it just occurred to me that I haven't been watching my questions. What are the risks of transpirational drying, including fire hazard? Yes, and actually Matthew Smith did a good job. He actually had a landowner group conference feedback, and surprisingly landowners were not that considered with the fire hazard, though the folks in the woods were worried a little bit about it. Yes, that is a problem, but I'm not worried so much about the fire hazard as I'm worried about 2 visits to a site. I mean, a lot can change in 6 weeks around here. What could be a high and dry site in one point, with the right rain or something like that, can become a pretty wet site. So that, coming from the woods, we always have this going back and forth. Coming from the woods, I would say I'm much more in favor of cutting and producing a green material, but I do know that we have to work with our people on the production and conversion side, and they want a dry material. And again, as I addressed earlier, is it going to be more advantageous/efficient/ cost efficient to dry in the woods, or is it going to be more efficient to dry at the plant? Again, that's one of the things that we have to learn as we move forward in our harvesting capabilities and, how we develop this machine. You lose the advantage of just-in-time delivery, more like switchgrass. Absolutely. Short rotation woody crops, and I assume that's where you're addressing that situation. Short rotation woody crops there's going to be some serious disadvantage in terms of time flow of the material if you're going to limit yourself to a window of harvesting only in the winter. And again, if we develop this machine, we may find that we put enough of a saw on it or a good enough felling head that we can harvest year-round. But my conversations with the folks on the tree side are telling us that they're very concerned about the destruction of the stool if we do, growing season harvest. And again, until this machine is something we develop and build the machine and actually get a chance to test it, get crops in the ground, first of all, that we can test it on, we're not going to have that answer. But I agree with you 100%, Tim. If you go with short rotation woody crops and that only harvested in the winter, what are you going to do for the other 8 months of the year? And that's going to be some problem. Transpirational drying will not necessarily be an advantage for biochemical conversion. Conversion is not actually carried out. Okay, Duran, now you're talking above my head. I agree. I think that's one of the places that we have to, as a group, come back to discussion. And I'm kind of, like I said, in talking to the conversion folks. First, I'll tell you a little story, and that is when we built our little conversion unit here with CPC out of Colorado. A group of us went out to Colorado and visited the site, and they were saying how the material had to be dry. And I said, okay, for this gasification process, we have no choice but to use dry material. Several months later, Tim McDonald took me to a brick plant down outside of Phoenix City, and I watched chips come in and going into this plant, and I asked the guy, how do you dry your chips? And he looked at me cross-eyed. He said, what are you talking about? We don't dry chips. We put them in green. So they have a gasification system that came out of Australia that handles green material. I'm just telling you what I'm hearing from my conversion people, and that is they seem to favor dry material, whereas I'm just telling you from the wood side, our being able to dry material may not be that easy. Back to short rotation, we may want to talk to Greenwood. They're working on a coppice for poplar as part of another IBIS project. Yes, I know. Unfortunately, I have not had much conversation with the folks out west. I know what they're doing on poplar, and I know what they're doing. And I've been out where they harvest it for green and put it to pulp mill. I have not been involved or found out much about what they're doing with their new project as it relates to their AFRI grant and airplane diesel or biodiesel, air jetliner fuel. And I don't know if they're drying the material or what they're doing with it. So Susilo said that if we're going to focus on gasification of pyrolysis processes, he desires a dry material. Again, my discussion there is just where is it most efficient to dry it? Is it most efficient to transpirationally dry it in the field? Does that get you down far enough? You know, again, recognizing there's operational and cost difficulties with that. Is it better to bring it in green, process it, and then have some kind of drying system on the front end of your pyrolysis gasification system? I'm not sure. To manage fire risk based on location. Yes, Matthew, you're right. I think you were the one that told me that you were surprised at the landowners that didn't seem concerned with fire risks. And I would say, from the standpoint of my knowledge of the industry and the locations, that's not going to be a big issue down here in the southeast. Yes, I mean, laying all this material on the ground, laying there, it could be, especially if something were to catch, it would go pretty bad. But we generally don't have the problem that you might see. If this was a West Coast thing, it would be a serious problem. But anytime you leave stuff on the ground, laying on the ground, especially as it dries and the needles and leaves and stuff get much more flammable, it could potentially present a problem. Again, it's not going to be my call, or I'm not the one who's going to say which way we're going with this. Are we going to dry in the woods? We're going to dry. That's going to have to be a group decision. I'm just trying to come up with a more efficient felling head. I said I wanted to do it where we could allow transpirational drying. It doesn't say that we have to. I just think that I think there's some serious challenges to the current machines that we see out there, named the New Holland and the BioBaler, because they process at the stump. Those chips then have to get transported from the stump and then moved into a trailer for further transport, and there's just a lot of cost and difficulties associated with that. And even if we can develop a head that harvests, cuts, and piles, we move it with a conventional skidder, again, all equipment that we know we already have and that's out there, then bring it to it and process it to a conventional conventional chipper. We know what the production capabilities are. We know the efficiency in running something like that. And that's the reason, again, that I think some kind of new felling head that reduces capital cost and leaves the material whole, that can be skidded or forwarded, it could be a cost advantage for short rotation woody crops. Yes, I was just over at a meeting in Europe last week, and there was a presentation on the amount of dust. And drying the material and then chipping it in the woods is going to create a dust problem. Like I say, there was an Italian study done on it, whereas in green material they didn't have any problem, but in dry material they did have some consideration. So, I would say, I know I'm towing the fence here. I'm a forester, so I'm all in favor of green. I want to go in the woods one time, cut the material, process the material, ship it green, and be done with it, and let our production people handle it. The bottom line is, that the production people are saying that may not be that's not what they want, and we just have to come up where we're going to meet in the middle. I hope you can make it if you're interested. Short rotation woody crops meeting. Yes, I know the short rotation woody crop meeting is in. I have it on my calendar. I'm still not committed to making it there, but I'm going to very much attempt to get me up to find out what they have going on, especially from the standpoint. I'd love to hear more from the willow production people on how they've doing with their New Holland machine up there. So with that, I think that's it. I'm ready for questions. I know I kind of missed a couple as I was going along there. If anybody wants to jump in with a microphone, I'll turn mine off for a second here. Sounds like that would be a good meeting for us all involved in logistics. Yeah, the New Holland machine also has been tested out west too. Thank you, Tim. I did not know the New Holland machine had gone out west. Yes, Steve, I think it's time that we do as a group get together and discuss, the direction we're going. I'm also curious on how our plantations came out of the ground. In terms of are we going to have a place to test this material on our stuff, or we're not going to be far enough along and we're going to have to look at other testing sites. Namely, I think there's some sites out in Mississippi, on the Mississippi Delta, that we might be able to test it. But those are some of the logistics things that we have to figure out. I have talked to Tim McDonald, and we've gone back and forth, and Matthew, and we've kicked around this harvesting head. Everybody has a little bit different idea. There are some definite challenges to developing this new harvesting head in terms of being able to cut the material and lay it on the ground and minimize the dirt and things like that. But it's the direction that I see this project going for the time being, with what we have to work with. I mean, the New Holland machine's out there. At any point in time, I'm sure we could get one, bring it down here, and test it if we can get some trees in the ground that would meet our criteria of what we see as short rotation woody crop looking like. I'm interested in coming up with something to solve some of these other challenges. So I'm going to turn off my mic for a second. If anybody wants to kick in and say anything or ask me a question out loud, I'll get away from this chat room thing.
Hey, this is Steve. I don't know if y'all can hear me, but I put a little note on there about the short rotation hardwoods that we had planted here. Tim maybe can comment on the ones at Tennessee, which I've heard did really well. We planted 3 in Alabama, 1 at the Tennessee Valley substation, which is outside of Huntsville, and those have done really well. The cottonwoods are 10 feet tall probably right now. Some of them, not all of them. There's a fair amount of genetic variability there, I think. The ones that were planted, there were cottonwoods planted at E.B. Smith, which is between Auburn and Montgomery, and then eucalypts were planted at Fairhope, which is way down south. And there was a little herbicide application issue that they had there, and they ended up with a fair amount of mortality. So we'll probably have to replant those next year. Jeff Wright and I talked about that a little bit at the Sun Grant meeting, so that's something that we'll probably have to revisit.
Okay, so I guess as moderator, I'm the one that's supposed to chime in on some of this. As you can see, Bob says that they're going to bring down a New Holland machine this winter in the South. It'd be interesting to see how it holds up. That's a big, heavy machine on marginally sized tires. And I think that's an issue that everybody's concerned about. And so he says in the South, I'm assuming he's talking about over in the Mississippi Delta region where there's some lots of short rotation crops that have been in the ground with the hardwood group over there. Matthew brings up, so in Florida and other places we have forest land clearings, reclaimed areas, so where does short rotation fit in the landscape? I don't have answers to that one. I'm just knowing that with farm crops getting, in demand and prices going up like crazy, I've talked to a couple of chipping operations that said, they've spent a fair, they used to do understory clearing, and they've spent a fair amount of time lately, especially in Florida, clear cutting 300 and 400 acre blocks that are all being converted to crops, to food crops. So you're right, that could leave short rotation woody crops in a bad spot. But I think we also know that there's going to be some marginal sites out there, marginal crop sites that might be able to go for short rotation woody crop. I also see short rotation woody crop being a smokestacks thing. I think it's not going to be for everyone. It's going to be when a plant or decision is made to site a plant, you could see 5, 6, 8, 10,000 acres, under the smokestacks put in the ground to help feed that plant as they, source it from all the things that we already know about, CCR and residue material, potentially loblolly pine energy plantations that the DOA project had, and that the short rotation woody crops would be another fit. I think we're all in agreement that short rotation woody crops is the high end. I mentioned Steve Taylor's low-hanging fruit on residue material. There's this hierarchy of material, and I know I feel short rotation woody crops is going to be on the high end. Yes, it's going to be another alternative, but if you don't have minimum transportation costs, it's going to be an expensive alternative. You're working on suitability mapping. Okay, so there's Bob's comment is what's going to be available. Again, I'd reiterate my statement. I think short rotation woody crops, knowing as it stands right now, you're looking at a fairly significant delivery cost, is probably going to be, more specifically a smokestacks issue. Wherever the plant is, you may see some within a 10 to 15 mile radius on, some marginal lands or some people that want to convert. It all comes down to economics. If you can't show a landowner where he's going to make money, they're not going to listen to any of this. So, I'm going to shut up again and see if anybody else wants to chime in.
Okay, anybody have any other questions or comments for Tom? Well, that was great, Tom, and you kept us on target here. We were just about at 1 o'clock. I would like to thank Tom and all of you for participating in our third IBIS webinar, and look forward to our next one in just about a month from now. So thanks for the participation.